Good morning, good afternoon, everybody. Thanks so much for joining this next episode of In a Nick of Time. Today, with Matthew joining us, we're going to be talking about decentralized communication. So it's going to be very interesting to see what actually was the reason as to why Russia was not able to win against Ukraine when they lost all communications and effectively lost the war at the same time. So it's going to be an interesting deep dive into communications and what is needed to be able to have resilience and security baked in. So stay tuned for another 9 minutes. We're going to get started soon. Good morning, good afternoon, everybody. Thanks very much for joining this next episode of In a Nick of Time. We're going to get started in about 5 minutes now with Matthew to talk about decentralized communications and why this is so critical for the next engagements on the military side, but also for any company to be able to be resilient and secure So stay tuned. We're going to get started in about 5 minutes. If you've missed the new store, store.inthenickoftime.tv, all profits go to the Fisher House Foundation. So check it out. We have quite a few fun t-shirts and other goodies for you to share with your family or loved ones or colleagues. Do that, and all of the profits go to the Future House. Every quarter, we're going to have a different nonprofit and new design. So if you have design ideas, send it to us. We will make it a cool T-shirt. And stay tuned for another 5 minutes, and we'll get started. Good morning, good afternoon, everybody. We're going to get started in a couple of minutes with Matthew to talk about decentralized communications. In the meantime, if you've yet to subscribe to the show, go to inthenickoftime.tv and you can subscribe to get notifications about our next videos and events. Also, we're going to be launching our Cloud Native Town on Gather in the next few days. So it's going to be a great space for people to share and learn and discuss different topics. You'll see pretty much everything around acquisition compliance, cybersecurity, DevSecOps, Kubernetes, and the cloud native innovations with a lot of the CNCF companies sharing their content and putting information there for you to keep up with the pace of relevance. So stay tuned for that. In the meantime, also check out our new t-shirt and goodie store.inanicoftime.tv to be able to get access to those fun t-shirts and check them out. All the profits go to the Fisher House. Every quarter we're going to have a different nonprofit, so stay tuned. We're going to get started in a couple of minutes. Good morning, good afternoon, everybody. Thanks so much for joining this episode of In the Nick of Time. We're going to have a great time today to talk about decentralized communication with an amazing guest that's been at the forefront of open source technologies to enable these kind of capabilities. And there's just nothing like it elsewhere. And it's really a game-changing concept compared to things like that, like Signal and WhatsApp and solutions like Mattermost and Slack and others. So this is going to be a very interesting discussion. We'll even be able to see how this relate to the Russian Ukraine engagement right now and why Russia has been losing the war because of communications. So this is so essential, obviously, when it comes to military engagements, but also to a lot of companies to succeed at doing their business. So this is going to be an interesting discussion. If you've not yet subscribed to the show, please do that at inthenicoftime.tv. We also wanted to remind you that the Learn with Nick is here. LearnWithNick.com, 50% off for military, civilians, and veterans, and 20% off for early adopters, now up to 3,000 with Let's Beat China. And you'll see new videos, new content, but you'll see also what's coming with the metaverse coming in the next few days. Before we talked about the metaverse, wanted to remind you that we launched the store, store.internetofTime.tv. All profits go to the Fisher House, so go check that out. There's a lot of pretty fun and entertaining t-shirt. Don't get upset. It's all parody, but it's all for good fun. And go check out the different designs. There's a couple of t-shirt that I particularly like myself. So go check that out. All profits go to the Fisher House for this quarter, and then next quarter we're gonna have another nonprofit, always aligned to military and veterans. So all going to great causes to make sure that our warfighter and veterans are taken care of in our nation. We're not a third world country, right? So wanted to remind you, we're going to be launching also in the next few days now, and you can see some early design here that's coming up with a space themed cloud native town on Gather. Unlimited free access for everybody. We're going to have all the CNCF companies pushing and publishing their content on there with videos and engagements and events. It's going to be a massive event space with 100, 500 to 1,000 people live. New videos, of course, from Learn with Nick will be there in real time. A lot of events, a lot of discussions, but also space for each company to be able to promote their products and what they've been working on and get feedback, but also dedicated spaces on different topics like compliance, acquisition, cybersecurity, Kubernetes, DevSecOps, and so on. So you can have private rooms to go engage with all the subscribers of In the Nick of Time and Learn with Nick. Many telcos, banks, Seven Nations, a lot of Fortune 100 and 500. So it's going to be a great place to go and share and discuss. And no sales, right? Just really learning and sharing and making sure that as a community we can do better. So our kids have a fighting chance of winning against China 20 years from now. So now, with all that, I wanted to bring in a few seconds our guest here, Matthew, who is a co-founder of Element, and of course also the CEO slash CTO. Is responsible for the technical vision and direction of the company. He's also obviously the founder and the co-founder of Matrix, and he's what we call a guardian of the Matrix.org Foundation, which is the open source project that obviously publishes the Matrix open standard. And you'll see that that brings you secure and decentralized and real-time communication capabilities, something that really you can't really find anywhere else. Often, obviously, all the other solutions are centralized and dependent on either a company to run it for you as a service. So very completely different model here. And so if you want to reach out, of course, to Matthew, is on LinkedIn as well. So let's bring him up on the screen now. Welcome, Matthew, to the show. We're so excited to have you.
Well, thank you very much for having me, Nick. It's a pleasure to be here. Can't wait to explain more about the weird world of decentralized communication and Matrix and Element.
Yeah, so excited to have you because honestly, with all the contributions you've made to the open source community through this Matrix project, I think people are going to realize, for people that don't know yet about it, that it is a great capability for them to consider to potentially not only replace and look at something else than Signal, WhatsApp, but even all the way to Slack and Mattermost and solutions like that. So we'll see how each of those can align and what are the pros and cons, right, and the difference in features. But before we get started, as always, I ask my guests to give us a little bit of a background on their journey, and yours is so interesting. Obviously, we want to hear from you first.
Okay, well, I guess the story of Matrix and myself is originally I was doing physics at university, ended up being moved over to computer science and met some guys who were building an instant messaging network. And this was back in the late 90s. I subsequently started working with them after graduating. First of all, doing lots of voice and video technology, but then subsequently moved more into instant messaging. We got acquired by Amdocs, a large Israeli telecom supplier, in 2010, where I ended up running their unified communications division, so building clones of Skype and WhatsApp for telecom providers. And then after a while, we started to wonder, what would the phone network look like if you built it from scratch using today's technology? And this was in 2013-14. And we wondered why there isn't a communication layer for the internet. Why do you talk on WhatsApp and Telegram and Signal and all of these silos? Why isn't there something like email or the web, but for real-time communication? And that's how we came up with the idea of Matrix, and persuaded Amdocs to fund us to work on it for a few years, and then spun out now to commercialize it Element, and Matrix itself is a non-profit software foundation that looks after this underlying technology. So you could say I've basically had the same job one way or another for the last 20 odd years.
Yeah, but of course, lots of great lessons learned, and obviously the landscape of the market has changed a little bit, but at the same time, very interesting foundation there. So it's always interesting to go back to the roots. That's why, for people, I guess that don't know, right? I was tracking the project, but maybe a little bit later than some others. So tell us a little bit about what is Matrix really. And it's not the movie.
Indeed, it's not the movie. We thought when we created it that we could borrow the name, and then of course the movie came back last year. But I think it's kind of fair play. The idea of Matrix is to be this missing communication layer for the open web. It is a protocol, so it's not a product. It's an open source project that defines a protocol for how you can do instant messaging, voice, video, or actually any kind of real-time communication over the internet. And the properties you get are that it is end-to-end encrypted by default using Signal-style end-to-end encryption, and it's decentralized, which means that everybody can run their own server, and that can be on-premise, it could be private cloud, it could be public cloud, it could be within your country, it could be in someone else's country, it could be buried in a mountain in Switzerland, it could be floating in international waters, it could be in space. We don't really care. Just like in email, anybody can run a mail server, and on the web, anybody can run a web server. Likewise, on Matrix, anybody can run their own Matrix server. Now, that's the protocol. On the internet itself, we do have a large public network of about 100,000 servers, and they are run by all sorts of different people. And it ranges from the entirety of the French state, who adopted Matrix as their secure communication platform back in 2018, I think now, so 4 years ago. It could be the German Bundeswehr, the entire armed forces of Germany, who again have standardized on Matrix. It could even be NATO, who, as of the last couple of weeks, have been experimenting with running Matrix servers as a way to communicate between all the various partner countries. Or at the other end of the spectrum, it could be individuals. Like I run one at home under my desk. I know people who run them on Raspberry Pis and put them under their beds or put them in the basement. You could run it on DigitalOcean or AWS or Azure, really wherever you like. And these servers range in size from small ones for just one people, one user, through to, I think the largest one's about 300,000 users on a single server. But the beauty is that they can all communicate securely together. So you're really replicating the conversation, so there is no single point of control or failure.
Yeah, so that's exciting. I mean, it's pretty amazing to see a single server running 300,000 users. I wonder what the specs of that machine. I doubt that's Raspberry Pi, but
no, it isn't.
might be
I can tell you actually. I mean, like on matrix.org, which is the original server that we set up 8 years ago, we've got at any given point about 200,000 simultaneous users. So it's not quite the biggest. I think some of the French ministries are bigger, but that box is actually 4 physical boxes, each with half a terabyte of RAM and about 20 terabytes of SSD. So it's a chunky box.
So, you mentioned a lot of nations and NATO starting to consume, the services for many years now. But yeah, I've not heard you mention, the U.S. government. Are we behind again? What's going on?
No, we are working with the US government. We've been speaking to various branches, in fact, for over 4 years now. In terms of traction, things are currently being trialed in various locations. And I haven't got sign off, unfortunately, to name drop who we're working with, but suffice it to say that it's folks on the West Coast who have particular interest in very decentralized secure communication, and that I guess the common military pattern is that you have a very geographically distributed set of folks in the field, dotted around the world, obviously HQs and data centers, but you want everybody to be able to communicate independently. If somebody takes out a particular unit, or if it is disconnected from the rest of connectivity, they should still be able to communicate within themselves. So imagine that you have a vehicle or a vessel. You want everybody on board to be able to talk to one another, even if they're running dark, if they're emission controlled. But then when they go back online and link up via SATCOM or HF or whatever medium, they should have their conversation synchronized with the rest of their unit and the rest of the organization. So that is how we see people, particularly in the DoD, using us today, because it's the holy grail of decentralized communication, giving everybody digital sovereignty right down to the individual personnel if needed.
Yeah, so we call that D-deal, right, in DoD, where not only you're decentralized, but you can also go offline and then reconnect and resynchronize, right, and so have that flexibility of still having kind of this air-gapped capability, and then connect back to the network and synchronize again. So that's obviously essential to most engagements, particularly when you start touching, deployments at sea and in the air, but also in space. So you mentioned space. Have you had engagements with teams in the space industry?
Yes, we have. We've been speaking to folks both on the UK and the US side about how you can apply Matrix in space, because that is the ultimate DDIL environment of disconnected, denied, intermittent, high latency networks, and it's uniquely well suited because if you have people in a spacecraft or a high altitude plane, then obviously they need to have excellent comms internally, both messaging and IoT data, because Matrix isn't just for human chat and voice. You can use it for cursor on target or tactical chat, etc., as a communication backbone effectively for your environment. And then if you're in comms with the ground control, then you can synchronize up to that. And there's also been a lot of talk about running Matrix in LEO satellite environments as a kind of orbiting back plane for communication in case you need to have that level of resilience to disruption on the ground. On the flip side, we've also had Matrix running over HF, though, for scenarios where your satellites might not be in the best connectivity, shall we say, then at least over an HF link, even down to 100 bits per second, we can trickle what we call the ultra low bandwidth Matrix transport, which is based on CoAP, the kind of IoT protocol used for light bulbs, where we use that to get down to these crazy low bandwidths and bounce it off the ionosphere on a HF environment. So you don't even need to be dependent on satellites. And we can thank the DoD for giving us the inspiration to see if we can get Matrix down to those kind of crazy ultra low bandwidth bit rates.
Yeah, that's actually so interesting, right? Kind of effectively the decoupling between the transport layer and different mechanisms of connectivity, and of course the different type of hardware, both on premise and at the edge, and of course traditional cloud compute and so on. That gives you a total flexibility, really, of running it pretty much anywhere you want, which is exactly how software should be designed, and that's what I've been pushing in the department for many years. Of course, some people, argue that you can get locked into a cloud provider, and that's okay because you can just piggyback on that investment and not worry about running it elsewhere. But I always, when I think of software in an organization like the DoD, right, you want to be able to run anywhere, and so not getting locked into a cloud provider or to a specific stack is so essential. So I guess, what's the technology behind Matrix in terms of like programming languages, and give us a rundown on the tech stack, I guess.
Yeah, gladly. So, I mean, as I said, Matrix itself is a specification primarily, and you can go to spec.matrix.org and, you can read a whole bunch of Markdown and Open API docs, which basically describe how clients talk to servers and how servers talk to other servers, and also how servers talk via bridges to third-party systems like Slack or Teams or WhatsApp or whatever. But the implementations are like legion, because anybody can go and write their own Matrix client or server. There is this really dynamic, vibrant ecosystem of open source developers who are going and building on it. It kind of reminds me of Linux in the early days, where the geeks realized that they could unseat Sun and Hewlett-Packard and Silicon Graphics, and with this Linux thing, nobody needed to buy Solaris licenses anymore or IRIX licenses. They could just go wild and kind of take over the asylum. And we see the same sort of thing happening now in communications, that people realize that they can write their own Matrix servers and clients. So practically the ones which we publish as the Matrix Foundation, which are heavily funded by Element, the company we set up in order to fund Matrix development. You have two choices on the server. You have one written in Python called Synapse, and there is a beta one written in Go called Dendrite. Synapse is the mature one that in practice everybody uses right now. Probably 98% of the deployments are using it, and it uses Postgres for storage, Python 3 for the actual programming language, and the Twisted framework for any Python developers out there. And it's set up so that it can scale very wide using Redis as an event bus. So you can have lots and lots of worker processes that handle things like, sending messages to other servers, sending messages to clients, receiving messages from clients, persisting them in Postgres, and all of them can separately scale out. And then on the client side, there are hundreds of clients out there. Now, the ones which we build at Element are intended to be the flagship ones, and there are currently 3 out there, one for desktop and web, one for iOS, and one for Android. And each one is written in its own stack. So we're not taking like a mobile web approach. Instead, we are doing completely native stacks for each platform, with an SDK underneath written in either Swift or Kotlin or JavaScript or TypeScript now. And then you have the app sitting on top. So for instance, the French and German deployments actually swap out the topmost layer of the stack for their own branded customized version of the app. In France, it's called Chat. In Germany, it's called BV Messenger or BW Messenger. It basically gives people the ability to really sculpt precisely what user experience that they need, what single sign-on, what features do they have, those messages, do they have location sharing, all of this good stuff. And then finally, we have bridges which go and link through to other systems. They're typically written in Node. So if you wanted to talk to somebody on XMPP like JChat or Slack or Teams, all of those are written as Node little
so
modules.
Bridges allow you to connect to other chat, right? Not bridges between Matrix instances of servers. It's more used to connect from Matrix to Slack or Matrix to something else. Is that correct?
Yeah, precisely.
Yeah.
And there are, I think, 120 different bridges now to different things. We can talk through to Same Time or iMessage or GroupMe or WeChat or Line if you're Elf in Japan or Kakao Talk if you're in Korea. But because they're quite easy to build, the community basically stepped up and everybody took their favorite chat platform and built the adapter that would allow it to natively talk to Matrix. And that's kind of why we called Matrix, because it ends up being this matrix which connects together lots of different heterogeneous systems, including, of course, the native Matrix ones. The difference, though, is that the native Matrix ones get to use end-to-end encryption, whereas if I'm talking from, say, Matrix through to SMS, then obviously SMS isn't encrypted, so the bridge will necessarily break the encryption in order to kind of expose the data through, which might not be what you want if you're optimizing for security.
Does it show up on the screen when you're talking to someone to an endpoint that's not encrypted? Is there a way for people to see if there's a bunch of different bridges on the same server? Is there a visible way, I guess, for the people to track the encryption status?
Yeah, absolutely. In Element, you get some shields which pop up on both the users and the rooms at the top by the title bar to warn you whether it's unencrypted.
You have rooms and you have users, so one-on-one, right? And then you have rooms that like group chat, right?
Yeah, I mean, actually in Matrix, we don't have the concept of one-on-one specifically. Everything is a room. So a one-on-one is literally a room with 2 people in it.
It's just a smaller room, I guess, yeah.
Yeah, precisely, which is a big difference.
You mentioned the native stuff, right? One of the issues I guess we see in DoD, for example, is how difficult it is to accredit and authorize, mobile applications and desktop applications. So a lot of people, particularly in the department, go to the web route. Do you also have a web version, or is just not even an option?
Yeah, no, it is. It is. So, I mean, as Element, we go and also build a client called Hydrogen, which is the lightest element. And this is tiny. It's like a 70 kilobyte download with HTML, CSS, and JavaScript. And it has the entire stack in there, including the end-to-end encryption as WebAssembly. So for environments where you really don't want to have a native app, and as you say, a mobile device managed world where you don't want to jump through the hoops, where the native app is a good example. Or if you wanted to have, say, a more covert app where you're running it in an incognito tab and you just want to quickly jump in, check your messages and hop out again, then that's what you would use Hydrogen for. But in practice, we do see that the native apps can be run in a mobile device management, EMM environment, and can be accredited. So for instance, the German one is all mobile device managed and accredited at the classification that they need. So it can be done, but it's obviously a bit of work to make sure that you're not using any APIs or features that are denied by that environment.
Yeah, I think that the issue you're going to find is there's no central place in DoD ready for MDM versus, compared to many other nations. So it ends up being a disaster, and even each service they don't really have a well centralized, MDM management and application approval process. So even just in the Air Force, it's a pretty massive lift. So most teams then, that are buying at the team level, then would go to the web route because it's just easier for them. There's no MDM option. MDM is really only used for government furnished devices and really only mostly for a very small amount of people. And so it's a challenge, and it's funny how something that simple that should be managed by the enterprise is not yet the case, and that creates a massive headache when it comes to mobile applications. So that's the difference with the Germans and the French and the US, I guess.
I don't think the French have got their
behind.
MDM either yet, if it's any consolation, and the UK doesn't either. So I think it might just be the Bundeswehr who got their MDM.
Pretty much everybody is a disaster. So anyway, all right. So we talk about the big picture now. I wanted to kind of really understand on a more granular level, right? Starting with Signal and WhatsApp. What are the differences between the implementation of Matrix and Signal and WhatsApp?
Yeah, I mean, Signal is kind of the diametric opposite of Matrix in many respects. And, we like the team there. And whenever I'm in San Francisco, I go and try to meet up with them and we compare notes and we kind of agree to disagree in the end. Because Signal is a fundamentally centralized service. You just have to trust one logical server that is run by the Signal Foundation completely.
Right.
So the good news is that they're good people and I'm sure they run it securely, but you still have that single point of failure and control where you've had to put all of your trust in those folks. It's also a very closed platform. You can't, say the web example, you can't build a hydrogen equivalent lightweight web app that talks to Signal, or if you do, you're breaking the rules. They're going to get upset. They're going to kick you off their platform because they fundamentally believe that they should control the client entirely. Does that make sense? So the idea is that in that instance, you're trusting them entirely. Whereas in Matrix, the whole idea is that everybody can run their own server. So you can run it on SIPRnet. You can run it air-gapped, doesn't need internet access. You can get the best people in your organization to run it. And then it's entirely your problem to make sure that it is locked down as securely as possible. Obviously, people like us at Element will help you provide the best practices to run it securely. But in the end, you have total sovereignty. You're not dependent on some random third-party company to run it for you as a centralized SaaS solution. So, for instance, it's embarrassing to see Signal getting blocked by governments in Iran who have figured out that there is one server there and they will block VPNs and they block anybody trying to talk to Signal. And then, hey, presto, nobody can talk securely via Signal anymore. Instead, they've all gone over to Matrix. And right now, Iran is like the 4th largest country on our stats on the Matrix network because it's the one technology that is actually working there because they can run their own servers within their own country and communicate securely with one another. And it kind of gets, it can cross the borders between the various different countries and find a way through the cracks in the firewall and the blocking because you have this big mesh going and trying to talk to the rest of the world. So it's really a fundamentally different philosophy. It's optimizing for freedom as well as privacy, whereas Signal is optimizing purely for privacy, and you don't have the freedom to build on it as an open platform or to run your own server or run it on your own terms. And you certainly can't bridge through to other systems because that would be a totally anathema for Signal because the last thing they want is for you to take your secure conversations and convert it to WhatsApp or something like that because the conversion would necessarily have to re-encrypt it, which then is a chink in the armor in terms of the attack surface. And comparing with WhatsApp, it's kind of even worse because it's centralized and it's run by Facebook, which is looking at the metadata of these conversations in order to better sell you adverts. And from a operational capacity, it's not ideal if you're in a public sector position and Facebook can see everybody you speak to, and they can infer the entire org chart of your organization, and they can tell who your family is, they can figure out who your contacts are, And okay, it's useful perhaps for them to be able to then sell you ads, but if that data gets sold to other data brokers like Cambridge Analytica or whoever it might be, it's just a privacy catastrophe. And frankly, if we were the bad guys right now, the honeypots, which I would be looking at, would be Signal and WhatsApp. Signal because it's marketed as the most secure thing in the world, and so any eyes you can get on the traffic coming in and out of that server will just immediately tell you who's talking to who. And on WhatsApp, it's what everybody uses because there are billions of people on the network. Perhaps less so in the US, but certainly in the rest of the world, it has become completely de facto the way to communicate. And you might think there is safety in numbers, but on the other hand, it's made an even bigger honeypot for the bad guys to go and analyze and figure out how to get at the metadata. And in both instances, you just have to trust the supplier completely that they are actually securing the conversations as much as they claim. Whereas on Matrix, you run it yourself, it's all open source. And as a government, you can get your agencies to go and audit it and analyze it, do vulnerability research against it, and you know precisely what you're running yourself rather than having gone and outsourced it to an advertising company.
Yeah, if we want to call it an advertising company, I don't know what it is now. It's pretty scary. Totally involved in too many politics too, which is never good. So I guess, how do you make sure that something is truly decentralized, right? Because a lot of people claim sometimes that they have capability effectively to just they think decentralized in a way of like resiliency and just have, I have multiple cloud regions. That's not decentralized, is it?
Yeah, we see a lot of bad marketing here where people declare that they provide data sovereignty because they give you a data center in your country. The fact the data center is run by a company in a different country who has complete control over it, it obviously undermines that data sovereignty entirely. And we see the same thing with decentralization, as you say, that there are many folks who declare something is decentralized because it's a private federation. Signal don't do this, but they could claim that they were decentralized because they run multiple servers in multiple AWS zones. But obviously they're not, because logically it's all run by one organization in one place, and you have to trust them entirely. Whereas in a truly decentralized thing like the internet or the web or email or Matrix, you can kind of prove that it's decentralized just by participating in it, that you can go and spin up a server or get one from a hosting provider like Element Matrix Services or many others if you don't have the resources to run it yourself. And you can disconnect it from the rest of the network. And it's going back to the military analogy earlier, it's as if you were sitting on a boat somewhere and then you deliberately cut your comms, and empirically, everybody can still talk to one another. And you can be damn sure that it doesn't depend on the wider network, because if it works perfectly when the rest of the network isn't there, then that's a pretty concrete way of demonstrating that you have that independence. And so last week, for instance, we took the big servers which run matrix.org and we upgraded Postgres from 12 to 14, and we actually moved it to different hardware. And so for the first time in a few years, we had an hour of downtime scheduled in. I think we only used 12 minutes of it. And we were so smug that we could tell the Matrix ecosystem, hey guys, we're going down for 10 minutes now, but you won't notice unless you're on our server, obviously. But everybody else won't be affected at all. So by the way, this is a great opportunity to stop freeloading on our expensive big server and get your own server, preferably from Element Matrix Services. But no, the entire world was able to witness firsthand that it's fully decentralized because we took out the one thing that could be the center and nobody noticed, unless, of course, they use it as their personal server.
Yeah, that's pretty cool. And so that gets me back to some of the open source project that I see. I was pushing pretty hard, for Google to donate, Istio, the service mesh, to the CNCF. They had created their own foundation, but governance, right? Open governance. If governance of an open source project is really managed by a single company, obviously, you're in a centralized universe. What you're saying here is also, it's not just about hosting and how many regions or cloud providers, right? It's also about who is running the service.
Yeah, totally. And that's something that has occupied a lot of our time over the years, basically engineering Matrix to be resilient from any vendors, including us as Element. So what we did was to set up a non-profit foundation called the Matrix.org Foundation. We did it as a UK community interest company, which is a little bit like a US 501c3, I think.
Yep,
But it's
that's right.
basically a non-profit with articles of association that mandate that it exists to support the whole ecosystem without privileging any given individual or vendor, and without kind of and rejecting patents or any attempts for people to kind of take control of the underlying technology. And what we do as Element is that we are contracted by the nonprofit in order to build out the foundational technology and the reference implementations, the servers, and the client SDKs on the various different platforms. And we donate that IP unilaterally to the foundation in an asset lock, so that even if Element got bought by Microsoft tomorrow and tried to relicense everything to be proprietary or do or patent everything, no offense to Microsoft, or we went bankrupt tomorrow, who knows what the failure mode would be. The idea is that the intellectual property, all of the open source that we built as Element, is owned by the foundation and is protected from whatever mess happened. And the other thing we do, controversially perhaps, is to let everybody preserve ownership of their code contributions. So we have thousands of people who have contributed both to the spec. Over half of the spec is actually contributed now from the wider Matrix community. And likewise, the reference clients and servers have got IP belonging to all sorts of people in there. Like Ericsson built the single sign-on for SAML in Matrix on the Synapse implementation. And there's a kid in North Germany who went and built the entire internationalization engine for Element in a summer holiday. I think he was like 16 at the time, didn't have anything to do, wanted Element in German, and so internationalized the whole thing. And often open source projects require that people sign a contributor license agreement that frankly, well, it goes and transfers the ownership of their IP over to the open source project, so that the company who runs that project can then commercialize it. Whereas we very deliberately have never done that. A bit again like the Linux kernel. If you look at the copyright of the Linux kernel, it's owned by all the random individuals who've been hacking on it. And the same thing is true of Matrix. So from a governance perspective, it really makes it owned by the wider community and prevents any single company, including Element, going and having undue control. And the board of directors for the foundation, we actually call them guardians because that is their role. They are guardians of Matrix. There are 5 of us, myself, my co-founder, who came up with the whole thing in the first place. But then we have 3 independent bodies. One is working at the EFF these days. Another is a professor at Cambridge University, and another is working with German public sector and used to be a CEO of a company that was building solutions using Matrix as their comms platform. So we are deliberately the minority. So even if myself and my co-founder go mad and try to patent everything or whatever it might be, the other guardians step in as a kind of checks and balances to stop us messing it up for everybody else. And empirically, this has worked from a governance perspective really well, because lots and lots of companies who frankly compete with Element are very happy to build correctly on top of the Open Matrix protocol. And as a result, you get a really vibrant ecosystem. One of the first people was Thales, the massive defense company in France, who went and took the reference implementations and turned it into a product called Citadel. And you can go to citadel.team and see Thales's secure comms solution that is powered entirely by Matrix. Or Palantir, another company who's gone and taken Element and its reference components and incorporated it inside their Gotham product. So empirically, the fact that a whole bunch of folks providing secure comms, whether it's in a defense context or education, healthcare, because for instance, Germany has mandated Matrix as the technology that the healthcare industry has to use to communicate for patient, doctor, insurer communication. All of these different verticals can build on the same commons without fear of a rug pull or it being undermined by a single vendor. So we serve the same kind of role with Matrix as the W3C does for the web or the IETF does for the internet, to make sure that you are building on a solid foundation. But the amount of effort that went into building the articles and the kind of constitution kind of felt like I was Alexander Hamilton going and writing out all of these paragraphs trying to define how this project could sustain for the next couple of 100 years. But that was 4 or 5 years ago now, and so far, touch wood, we haven't had any governance disasters.
Yeah, that's very good. And now you're gonna have to rename Guardians, with the Space Force using Guardians as a term. I don't know if that's gonna work for you guys anymore. I don't know. I think they
we might have to go back to calling them directors, which is boring, but at least it's accurate.
They ruined it for you. I was never a big fan of the term, anyways, but whatever. All right, they wanted to look, play the young crowd and be fancy, but I think that I don't know. All right, so let's look at obviously what comes next, right? Because decentralized sounds good, but then you're talking crypto, and now you're talking, well, we have to manage keys. So how does that, key management happen if you're in a decentralized universe?
Yeah, no, excellent question. I mean, first thing to understand is that the end-to-end encryption in Matrix is kind of a necessity. It's not just because we like privacy, it's because that in a large chat room, it gets replicated over all of the participating servers. So you can't talk to somebody on a different server without sharing ownership of that conversation with them. So in the biggest rooms we're aware of, you get about 100,000 users spread over about 10,000 servers. And so the kind of data footprint of that room is replicated on 10,000 servers who could be very variable levels of quality in terms of how well they are sysadmined and how well they are protected. So you have to encrypt the conversations if it's a sensitive thing. Obviously, it doesn't make sense in a public room, but for a private conversation, if you don't want the plain text to be replicated over these random unassociated servers, you have to have end-to-end encryption. Now, the keys themselves come in 2 flavors. There are the identity keys for the users, and they are stored on the devices where you log in. And when you log in on a new device, you typically transfer, or you prove that you own that device by scanning a QR code on it, or possibly comparing a string of data like an emoji to be sure that there isn't an attacker between your existing device, like your browser, and the phone where you've just logged in. And then separately, you have message keys, which actually decrypt the keys in the conversations. And these get stored by default on your devices, but you can optionally back them up to the server. This is a bit controversial because the second that you've taken all your keys, you encrypt them and you back them up on the server, then there is effectively one secret, that passphrase that you use to encrypt them, which could be used to get at your history. So some people choose not to use that. For instance, France doesn't use the online backup feature right now, and instead the keys are stored on your browser or app or endpoint, your phone basically, and it's up to the user to decide how to manually export them and put them into cold storage.
Yeah, so they would have to back up those keys somehow if they wanted to make sure they have some disaster recovery for the device. But can you have multiple the same user on multiple devices?
Yep. Yeah, very much so. So each device is modeled as a separate encryption endpoint, which is great because you can then block particular untrusted ones from conversations, and you can spot the moment that somebody adds on a new device. And if you're feeling particularly paranoid, it might be, hang on, Nick just added another 3 devices, and I might check out of band that, no, is that really you, or did somebody guess your password? And we also have the concept of cross-user verification, and this is really ensuring that you don't have a man in the middle intercepting you. So that right now, for instance, we could take up our elements and I would hit the verify button and we would read out a passphrase to each other. And if that matches, then we know that unless there is a very sophisticated attack going on, in which I'm actually looking at a deep fake of you right now and they're switching the passphrase from me, then you're pretty confident that you're talking directly to that other device. And the cool thing is that as you log in on other devices, as you have to authorize that device when you log in, you'd pass the trust to your other devices. I will never need to verify you ever again. Having done it once, it will last forever. And one of the things we're working on right now is transitive trust, where an intermediary could vouch for us. So, for instance, if I onboard onto a particular organizational unit, the person who hands me my phone and installs the app will also verify at that point that there isn't an attacker between the new device and the person who authorizes it. But then through that admin, you would trust everybody else in the organization. And obviously in a DoD context or any large public sector or private sector org, it's practically much more useful to have that transitive trust rather than having to go around everybody individually and having to check that they are who they say they are before you can talk to them.
Right. And so if someone has multiple devices, let's say a laptop and a phone, do they see the same messages, or they're considered as different identities in a sense of the crypto keys being stored on each device? Or are they sharing the keys between the laptop and the phone?
They have the same history on both devices, and hopefully they will have the keys needed to decrypt the history on both devices. Sometimes that might not be true, because obviously if you have just logged in on a new device, then it won't have the keys. And so either you need to restore it from online backup, or you can gossip it between the devices if they explicitly trust each other. This is obviously a useful feature because it means you can synchronize up your conversations transparently. It has the disadvantage that both devices have to be online at the same time, which is sometimes hard, like if you're migrating from one to another, or if you lost your old device, then if you didn't have a backup somewhere, you're screwed on getting the keys back.
Interesting. Yeah, that makes sense. So I guess what's the risk when so you said people could back up the keys to the server. Does that mean the server, if it's the use case where you had 10,000 servers with 100,000 people, does that mean the keys are shared to all 10,000 servers, I guess, in that use case?
Yeah, so if all of those users were backing up their keys onto their respective servers, then yeah, you're going to end up with 10,000 copies on the 10,000 servers, each protected by a different passphrase. But all it needs is for somebody to have used secret or Hunter 42 as their passphrase, and that could be bad news. Of course, by the time you've got 100,000 people in an encrypted room together, the human leak factor is massive, because inevitably somebody is going to be taking screenshots or copy pasting the logs onto Twitter, or frankly bridging it through to email. So we don't recommend using encryption on large public rooms, because if it's public, it's public. Why bother? What are you protecting? You're just wasting CPU and resources.
Right. That makes sense. All right. So now, obviously this could potentially be completely air-gapped, right? And so government on the classified side could run this.
And they do. So there are deployments out there on SIPRnet, and hopefully I'm not breaking anyone's rules by saying so. And in order to run it in SIPRnet, you obviously need to have the entire build chain operating in an air-gapped environment. And we also have high-side deployments in other countries as well who have very similar requirements. And the beauty is that it's all open source, and you can see precisely the source code that has to go through the accreditation process to be scanned, as well as generally analyzed, to lock all the dependencies and pin them to make sure that no nasty supply chain attacks are creeping in. And then once you're happy, you cut it and you burn it and you deploy it high side. So another really fun thing that we have, I can't remember if we've got it to talk about today, is cross-domain functionality. So not only can you run it in a high-side classified environment, but we have worked with hardware device manufacturers for doing cross-domain guards in order to then actually get the traffic to go
push to the high side.
Both push to the high side and go down from high to low with the necessary data loss protection rule sets to make sure that obviously nothing classified at a high level ends up on the low side of the link. But it's
is that considered a bridge in that case? Is that a bridge, or is that something different?
It's actually its own thing because it's effectively a bump in the wire on the server-to-server traffic. So you literally will have a low-side server and a high-side server, and you have the
Oh,
appliance
I
sitting
see.
between them, which has got a data diode or an FPGA in it that is forcing the data to go unidirectionally. So typically you would run two of them, one for one direction and one for the other direction. And it is capable of breaking the entire matrix protocol down, including the end-to-end encryption, really splitting it up into its component parts, scanning it for whatever you are looking for, and it could be file transfers would get looped through a separate cross-domain share solution like a glass wall or something like that. Or the VoIP side would also be split out, converted into SIP, and run through an existing VoIP SIP cross-domain function, and then reassembled from scratch on the other side and sent on its way. Now, obviously, this is deliberately man-in-the-middling our own traffic, which we've obviously built to not be man-in-the-middled. So for that to work, you have to extend the user verification process that we spoke about earlier, so that you can spot that a benign man in the middle has been there, and that yes, you know that the cross-domain gateway obviously will have broken down and scanned and reassembled your traffic in order for it to go across the gap. But that's okay because it was our cross-domain gateway. It wasn't a nasty one further down the line, or heaven forbid, inside the classified environment. So lots of fun problems to be solved there, and it's something that we've been working on over the last few years, initially with the UK, but then with other governments, making sure that we have cross-domain matrix capability.
And you have any CDS that's from the US as well?
Yeah, so we work with OWL and their sort of local reseller in the UK, and have it running on the OWL hardware set. And we've designed it in a very modular manner, so you can run the whole thing in software if you want, although obviously you miss a lot of the fun because you don't have the actual hardware break between the networks at that point. But if you're doing sort of equivalent classification levels, like going from, I don't know, official to official or something, that might be fine. Then you have the ability to use commodity off-the-shelf hardware like the OWL data diodes, which we work with them to get it up and running. And then if your government happen to have more bespoke hardware solutions for higher classification environments, then we build drivers which plug into that in order to integrate it.
That's very cool. And so do you see, I guess, is there a need to have the keys of the messages in the CDS to be able to break that encryption, I guess? I mean, it's all the keys are backed up right there.
Yeah, well, the interesting thing is that it's only the identity keys rather than the message keys. So the message keys themselves would typically go all the way through from one side to another. But the CDS acts as a kind of back-to-back system where it's terminating the traffic entirely as a fake user on one side of the gateway,
Right.
decrypting it, messing around with it, verifying it, reassembling it, and then sending it out as another user. So you effectively have a ghost or a kind of mirage of the user on each side of the gateway, representing the one on the far side. So yes, the identity keys for those mirage users stack up there, but the message keys themselves get passed through and are typically reused to reassemble, unless, of course, you're worried about that being a exfiltration channel, and then you can go and figure out how to create your own keys.
Yeah, interesting. That's very cool. That's a game changer right there. So, what about devices? Are you doing anything in terms of verifying, is there the device identity? How do you make sure the device is the actual device, I guess?
Yeah, so I mean, we touched on it earlier. The two main ways are either that you scan a QR code and you rely on the fact that somebody hasn't hopefully somehow inserted a magical abusive QR code in the way at the point that you're scanning, both between your own devices and with other people's devices, or you can go and compare typically emoji, which might sound a bit stupid, but frankly, it's a bit more fun than calling out a bunch of numbers or letters to one another. And because there are so many emoji, you can get it secure enough with only 7. So if I were to verify you right now, and I did it via emoji verification, then you'll get 7 emoji pop up on Element on your phone. I will have the same 7, and I would say, "Hey Nick, do you have banana, pig, pig, smiley, hammer, hammer, chisel, or whatever it is?" And I mean, it's silly. I mean, but it's kind of fun, and particularly for consumer and enterprise, it's okay. I have to say that some of our defense customers didn't like the idea of having personnel yelling banana, banana, banana to each other. And so we also now support number-based and alphanumeric. But you have to have 14
they love
numbers.
The alphanumeric. I'm sure they love the spelling the military alphabets.
Yeah, well, precisely. You can just go and expand it out into
Bravo,
Alpha,
Charlie.
Bravo, Charlie.
Yeah, they love that. No doubt. Very cool. So does that mean, I guess, the device get a certificate, a key, like a unique identifier as well, or no?
Yeah, so every device goes and creates its own identity, which is a key pair, typically using elliptic curve 25519, which is what Signal and many other things use for its key exchange. These in turn can be signed, and you could tie it into an X509 certificate tree. And certainly some of the conversations we're having with DoD involve linking it through to the common authentication card style X509 tree in order to prove that the user's identity is who they say they are right from the point that they swipe their card into their terminal. And then they don't need to mess around with any of this verification. They're using transitive trust, but through the X509 certificate tree. But given that not all users have smart cards, and because Matrix is intended to be so decentralized and heterogeneous, it would be a disaster if the folks in DoD with their CAC cards can't talk through to people in NATO because your NATO partner happens not to have CAC. So we need to be able to fall back to emoji comparison or QR code or a transitive trust model, where as long as, I don't know, the defense attaché for one country has trusted the identity of a defense attaché from another country, then they can vouch for their respective organizations or something like that.
And that would be a game changer for the mission partner environments, MPE, and the work of the team MPCO that's trying to do this for the 58 nations. That's not just NATO, but a lot of the mission partners of the US, and they've been struggling with chat and basic communication features, particularly when it comes to identity federation as well. So that's something we should probably talk about, because that's I'd love to make an introduction for you there, because that's a big team.
So I can actually talk to that specifically, and I think I can talk about it publicly. I know I can talk about this one publicly. That we did participate in Bold Quest as the MPE exercise that the US runs typically every year to test this problem. And for Bold Quest in I think it was 18 months ago now, did take place over Matrix, particularly between UK and US. And it was fascinating seeing the problems, particularly around identity, and also bridging through to the existing systems that everybody has in place. Because we don't expect everybody to suddenly drop everything and move to Matrix. There are massive Skype for Business deployments all over the place, or XMPP or JChat. And so we were looking to see, could we bridge it together and provide a common language? And it worked really well. So we're getting involved.
Why did it not make it the way forward, I guess? Did they tell you what happened after this engagement 18 months ago, I guess?
It has been progressing since then, to be honest. I think the problem with exercises like Bold Quest is that it's more a box-checking exercise to check what you can do and how it works and get a data point on it. And then off the back of that, a whole bunch of conversations have emerged with folks who I probably should have checked before the podcast, whether I could name drop them. So, I mean, things have been progressing off the back of it. And I think we'll be participating in the next MPE equivalent one happening in 2023 to kind of take it to the next level. But the reality is that sometimes the defense apparatus doesn't move quite as fast as the tech companies, as I think you may be an expert on.
Yeah, yeah, no doubt. All right, so let's see. Another big problem that countries like France and many others are complaining about when it comes to hosting and data sovereignty. They're struggling. They want to build their own clouds, but they realize it's billions of investment, if not more. With competing against someone like Amazon or Microsoft, and then they go to OVH and they realize they're 20 years behind, and it's not the same quality and services. But then, of course, there's a data side of, hey, can we host this stuff on an untrusted hardware? Effectively a dirty transport, dirty hardware. What's your take when it comes to potentially, deploying this capability on top of effectively what would be considered untrusted hardware?
Yeah, I mean, the fact that everything is end-to-end encrypted for private conversations means that it's uniquely well suited to running on random dirty hardware around the place. And we've seen situations where the hardware is literally dirty because someone has compromised it. And we had a breach on the matrix.org server back in 2019 where, unfortunately, an attacker had got root on some of our servers. It doesn't get much worse than that. And the one good thing about it is that they didn't get any data because it was end-to-end encrypted. And if that had been a Teams deployment or a Slack deployment or XMPP or Skype for Business, then it's kind of game over if you've got an attacker who has got that level of access. So yeah, data sovereignty.
What could they see? Is there something they could see, like who's talking to what? Can they see any kind of telemetry there?
Yep, it's true that they can see the metadata of the timestamps of the messages and the rooms that they're happening in, although we are working on improving the metadata footprint of Matrix. One of the tricks we're doing is to give users a different identity for every conversation that they're in, so that even if an attacker has seen the metadata...
Short-lived identities, yeah.
Yeah, basically on a per room basis, that already gets you a lot of the way there. And if you start rotating the identities as you go on, we have the concept of room versions.
Do rooms have identities? Could you rotate the room names?
Yep. That was literally what I was going for. We basically built the idea of ratcheting into the protocol so that as we upgrade it and we do things like change the identities or change the encryption or change how you replicate, you can actually upgrade any bit of Matrix and then declare you've got a new version of the protocol and migrate people onto it. So right now we're on version 11, but no, it's just Matrix in the end. And typically the upgrades are invisible to the end users because it rarely touches the thing that the client actually sees. So for instance, you could keep upgrading a room every day to a new version of the same room at the same protocol level with a different ID. And so you're almost kind of frequency hopping your way around the network. And you could put them on different servers running in different environments. And well, there's a lot of flexibility in how you could go and obfuscate that metadata if you wanted to. But honestly, today, right now, people don't tend to do that. If somebody looks at a given server, they would see what users exist on the server and who's talking to who and when. But that is, as I say, an open area where we're trying to fix things. Another thing we're doing is peer-to-peer matrix, which you can check the latest status of at arewep2pyet.com. And in peer-to-peer matrix, you put the server in the phone. So we take our Go server stack, we compile it down to run within the actual iOS or Android app, and therefore you don't have a server anymore at all. The two devices can talk to one another over a mesh like ad hoc Wi-Fi or Bluetooth Low Energy or just plain old IP over 5G or whatever it might be. And that has the ultimate data sovereignty because you've got it in your pocket. And there isn't a server for people to get root on and look at the metadata anymore, let alone the data, because the servers become optional. The catch is that you need to have some kind of relay point so that if you have, say, a few weeks ago, we were at a conference called Atlantic Future Forum, and that took place on the UK flagship aircraft carrier, Queen Elizabeth, which was docked in New York Harbor. And the problem of having a conference on an aircraft carrier is that if you're a civilian like me, you're stuck in a big Faraday cage with no GSM whatsoever and no civilian Wi-Fi. So we felt very, very smug. There were 5 of us there, and we spun up peer-to-peer matrix and created a mesh network like that over Bluetooth Low Energy, which has got a pretty good range, particularly if it's bouncing off the sides of your Faraday cage back at you. And we're able to chat during the conference. The only problem is that if everybody was offline at any given point, there was no way to open up the app and tell the others that they needed to get online, because there wasn't any kind of relay point or common bearer between them unless they happened to also open the app. So there was quite a lot of like waving across the room with a phone saying, oh, I'm trying to send you a message. And then they would open up the app and you'd be able to send it through and synchronize it. But we're working on that too. In fact, there's a guy working on it as we speak, implementing store and forward relays, which are effectively very dumb dead drops, which can take these messages and relay them on their way when the other server comes up, and they're privacy preserving. So you wouldn't be able to see immediately from the metadata if you inspected one of those dead drops on who was trying to talk to who. So, I mean, this stuff is sci-fi, it's quite R&D, it's looking promising, but it's probably at least 6 months away from being usable in anger. But that's one of the extreme interpretations of data sovereignty that we're going towards. And it allows for a hybrid effect where you can have your normal mesh of servers and people communicating as they are today, but you could also participate with your local server and your phone, so that if you do go into a truly denied comms environment and still want to talk to your buddies or whoever it might be, that you can have this sort of really heterogeneous mix of mesh peer-to-peer and conventional federated decentralized comms.
That's pretty cool. I'm pretty sure Russia would have liked that, having this instead of getting their ass kicked. But I guess question on the we didn't talk about deployment, but do you have a version of this whole stack containerized and someone can run this on Kubernetes or
yeah, absolutely. I mean, it doesn't have to be containerized, but right. We recommend it. And as Element, we provide a thing called the Element Enterprise Installer, which takes the entire stack and provides it as a Kubernetes operator, actually developed initially for DoD customers, where it can run against Red Hat OpenShift on AWS or equivalent. So OpenShift deployments, basically. And it's great because you just hand the operator over and it pulls in all of the dependent containers, of which we're up to about 200 now, dependencies for all the different moving parts if you want your bridges and you want your different scalable workers, etc. And it abstracts all of the complexity from you. Well, and we've also seen that used running in the field on Windows laptops, using Docker for Windows, and having it in a ruggedized laptop so that you can have it at the end of a SATCOM link for the DDIL environments that we were talking about earlier.
Yeah, that's pretty cool. Sky is the limit, no doubt. And the beauty there, of course, with moving target defense is just like you can have short-lived identities, you can also have the containers effectively be short-lived and go back to cattle and making sure that no malicious actor are sitting in that container and exfiltrating data or the telemetry we talked about or whatnot. So very cool. All right. So now, obviously you can have a bunch of servers, but can you federate those across nations? Like, I mean, I guess the MP use case where potentially, France will be running their stuff, UK, US, could they federate that and have a kind of a federated matrix?
Yeah, absolutely they can, and they do. So with countries specifically, everybody seems to start off doing it internally, and then they often do it internally in multiple places at the same time, because obviously you can run it in different departments and agencies and organizations and start off thinking, hey, I've got it for myself. Oh, wait, I can see other people on it too, assuming, of course, that you turn on the federation and you have it visible inside your network. And we do see people then going cross-border, using it for alliances, like the NATO use case, obviously, but also within particular industries. I keep mentioning Germany because I guess they're really big on privacy. And In academia, I think there are now 150 universities in Germany, Austria, and Switzerland who have adopted it. And they use it within your university. But then if you want to collaborate with somebody in academia or elsewhere, you can spin up an end-to-end encrypted room that is equally owned by either side. And the beauty of Matrix is almost a political one in the end, in that it solves this age-old problem of whose system do you use to talk on, because each university will feel that they own their infrastructure and that the conversation is hosted on their infrastructure. They haven't ceded any control to their arch-rival competitions elsewhere, and yet they can still talk to one another. And the same goes within defense or government, or two allies who perhaps aren't quite as allied as they should be. They can still communicate without grumbling about the fact they got having to use the Ruritania chat platform. They should be using their one instead.
Yeah, one of the issue with MP is we cannot let other nations know sometimes that we're chatting with some of these nations. They're not supposed to know that we have bilateral agreements between the nations. Could you do that? And could you label like group chat or rooms, I guess, to make sure that data can be tracked in terms of like, okay, I want to have this room just for SecRel to Germany, so it can only be US people and German people in there. Could you do something like that?
Yeah, absolutely. I mean, it all goes with the cross-domain gateway stuff. I mean, it doesn't have to be enforced with a hardware cross-domain gateway, but we have the tagging capability that you can put whatever rule set is needed on a per room or a per user basis to make sure that if you happen to have a chat room that is classified at a particular level for a particular community of interest effectively, then you can loop them in as required. And you really exploit the fact that Matrix itself is a very flexible protocol, and you can describe you can put any kind of metadata on your messages. So it could be, I know, long and lat data for cursor on target stuff, annotating your existing message, or it could be, I know, translation into a different language, or it could be an HTML rich text version as well as the kind of boring plain text version, or it could be a whole ton of free-form classification labels, whether it's no fawn or whatever labels you need to apply for a particular MP conversation. And again, it doesn't have to be controlled by either side, because the US might have its MP classification system, the UK might have a different one that has some overlap, but you can apply the labels and get the overlap, the intersection between the two that is then applied for the content on the both perimeters of the conversation. One way of thinking of it is that every conversation you have with anybody is intrinsically bilateral or multilateral, depending on who is there, and then you can lock it down additionally with the labels to make sure that it doesn't come up on other people's radar.
Yeah, so really, you're checking all the boxes for an engagement like MPs. I'm still struggling as to why they have not went all the way to production and make it the default, because they've been working this for 7 years now with very little to show, and I think it's time to stop these stupid demonstrations and really bring real capability to the warfighter. For people that don't know, this is the most important network that we would be using if tomorrow we go to war against China or Russia or whatever. So that's probably the most important IT engagement on the planet. So we're done with wasting time, and I've been trying to convince the MP leadership to wake up, and we got some new people there, so I think it's perfect timing to bring this up on the table again. So I'm going to take that as an action myself to reach out to them directly and to the Secretary of the Air Force as well to kind of bring this up again. So
no, thank you.
Let's look at.
Appreciate it.
Oh yeah, no, it's all for the nation. Is this? I guess the whole context is pretty complex for individuals. It's great for organizations. Everything we talked about, right? Of course, they can come to you and pay you some decent amount of money to run it or help them build it. But what about the individuals? Can they just Signal? I mean, I use Signal as a person. Can people do that too with your Element product as well?
Yeah, absolutely. I mean, you can go to element.io right now, or go onto the app stores on iOS or Android and look for Element and download it and start playing with it. By default, it will create an account on the matrix.org server, the original one that we set up, just to make it easier for people to not have to pick a server or find one. I mean, there are lists out there on the net of hundreds of open public servers, but frankly, I have no idea who runs them, and I wouldn't be able to vouch whether it's going to go and disappear tomorrow, or whether it's run by somebody you can't trust. So just for simplicity, we point them at matrix.org. And as I said, there's 200,000 people on it right now. There are about, I think, getting on for 10 million accounts in total over the years, although some of them are linked through to other platforms. And
how much do they cost, I guess?
Yeah, interestingly, a lot of people using it are basically trialing it for their workplace. And going back to the Federation story briefly, the MPE story, the reason I think we haven't had traction on MPE is simply that NATO published a bunch of standards called Federated Mission Networking that describe how you should do comms within NATO, and therefore there's obviously overlap with the MPE environment. And it's all based on XMPP, which is a venerable interoperable chat protocol, which is, I think, 23 years old now. And no, it gets the job done, but it's very much focused on the classic instant messaging, kind of MSN Messenger style experience, rather than a WhatsApp or a Slack or a Signal or a Teams kind of
completely outdated. Yeah.
So if NATO went and standardized or described how Matrix could be used, then not only would all the NATO countries start using it too, but it would be more obvious for the MPE environment to start using it as well. But the good news is, as I mentioned right at the beginning, NATO have started to pick it up and experiment with it. So if they start to ratify it, then it's much better than me as a CEO of Element saying, "Hello, I'm a vendor, please use my technology," or me as a Matrix non-profit guy saying, "Hello, I'm an open source hippie, please use our comms technology." It needs to have that kind of snowballing effect, which I think we're starting to see develop. But yeah, on the consumer side, absolutely go and take it for a spin. We haven't focused as much on it as, say, Signal, because frankly, our day job is frantically making sure that all of our massive government customers are happy, rather than building a consumer chat product like Signal or WhatsApp. But it can be used for that, and I use it to talk to my friends and family.
Is there a cost? What's the cost per user, I guess, for individuals?
It's free. So if you're using the matrix.org server, it's free. If you want a server of your own, then you can get one from Element Matrix Services, which costs, I think, $3 per user per month. With them. Yeah, so just $3.
Pretty cheap.
Deliberately, because I guess we want to undercut Slack more than anything else.
Well, it's not very hard when you look at the pricing. So and I don't know if you look at the Slack Gov pricing, but it's even worse. So back to your point, by the way, on MPCO and the standard, XMPP obviously completely obsolete. The FMS standard are pushing that still to this day. My take was, ignore this freaking FMS standard and just start delivering capabilities to the warfighter. That makes sense, and people are going to jump on it and start consuming it. Don't mandate it. Just say, hey, if you want to use it, you can use it. If you want to stay with your XMPP crap, you can do that too. But if you want to see the real life and 2022, join us in the modern universe. And I think the US is just hiding behind this excuse of NATO not changing the standards, and I think that's a bogus excuse. The real life would be to say, just let's deliver capabilities, see if people like it, and then see the consumption of it, and you will see people consuming it. And maybe 10 years from now, the standard would be updated because it's now used by everybody anyways. That's probably what it takes to update these standards anyway. So it's just, there's nothing that stopped them from starting to consume something like this in the meantime. So
yeah.
Anyway, I was pretty deep in MPCO, and I can tell you it was also probably the most toxic team I got to meet in the Department of Defense, and God knows I worked with hundreds of them. So the government side particularly was very, very outdated and stuck in time and with a stick in there. Well, you know what? So it's I'm gonna say it so you don't have to say it. it's a very toxic team, and we need and the world needs better, because this is putting not only the nation, but our kids and also all the NATO partners at risk by not having communications. You take an aircraft carrier in the UK going to Asia, they would have to change 5 times devices just to talk to the US, because of these 58 networks that couldn't be flattened, despite my team bringing the first flattened secret rail network to flatten the 58 networks, and MPCO refusing to use it. So anyway, lot of story there. But good news is there's new people. It's also now with a new leadership at the Secretary of the Air Force level, which with the Secretary Kendall, a high desire to start delivering actual value instead of paperweight, strategy documents. So anyway,
excellent. Well, that is literally the problem we're trying to solve.
Yeah. So I guess you have a paid version, right? There's open source stack. First, all the paid features open source, or all the closed source, and then what's the differences in terms of features between the paid service and the open source stuff?
So, I mean, some of the paid features are just us running it for you. And if you were using the SaaS offering, then everything we run in that SaaS environment is open source. You could run it yourself, but frankly, who's got time for that? I mean, if you're a government, sure, you're going to have the IT resource to go and run it for you. But if you're a smaller organization and you just want to have the data sovereignty to point your own domain name at it and then outsource the admin to us, then that would be one of the things which we do as the SaaS offering. But then for the more sophisticated stuff, things like cross-domain gateways, no, we don't open source that. And the rule of thumb is that if it's something that is only applicable in a big enterprise or public sector environment, like cross-domain, or perhaps audit capability, or regulatory compliance, secure border gateways, all this sort of thing, then those are typically proprietary paid features that we use to try to keep the lights on for Matrix. And the whole operation of Element basically exists in order to generate funding, in order to work on the core foundational work for Matrix itself, hence going and doing these sort of proprietary bolt-ons and providing defense products, etc.
Yep, makes sense. So I guess at the end of the day, this could be much more than just a competitor to Signal and WhatsApp, right? What about what you see on the Teams and Mattermost and Slack side?
So actually, the typical way that people use Element today is as an encrypted alternative to Slack, Teams, or Mattermost, because it scales up to these big conversations. I mean, I'm personally in about 6,000 chat rooms right now, and I looked at my account the other day, and it can see 450,000 people out there in all of these different rooms. And we have a concept called spaces in Matrix, which is a hierarchy that allows you to kind of group your conversations into a sort of folder hierarchy, but you can also have the conversations in multiple ones. So for instance, we have a hierarchy for NATO, and it's like 8 levels deep, and it's however many tens of thousands of things wide. But you also have ones within the UK Ministry of Defence, or US DoD, or education, or the World Wide Web Consortium just span up a space this morning, I believe, for all of their projects, etc. So the typical way that people do use it today is very much as this big kind of, we call it a banquet experience, where there's thousands of people running around trying to get stuff done and it's not just their org because it's Matrix, it's cross org, it's working with the general public. Now, more recently, we've also started building solutions which look and feel a lot more like Signal or WhatsApp. And the Element mobile app at the moment does both. That it starts off looking like WhatsApp, but then as you add more spaces in, then it kind of more functionality gets revealed until if you try hard enough, it ends up looking like a Concorde flight panel functionality. But we also have an app called Element X, which is our next generation of Element. And it's actually built on an entirely new stack. It uses Rust as a shared library between both iOS and Android, and to some extent web. And then we've gone and taken the best possible front-end primitives. So on iOS, it only runs on iOS 16 and later, using the latest Swift UI stuff. On Android, it uses Jetpack Compose, which is kind of the Google equivalent to Swift UI. And the app that we built on it looks and smells probably more like iMessage right now. It's like really minimal, but super fast and super responsive. And I think we will do the same trick that we've done on Element and let it organically grow to support the big collaboration use cases as well as the messaging ones. But we deliberately started off with the first release being laser focused on what we call the barbecue use case. So the small friends and family get, the 10, 20 people who you need to talk to as a messenger super fast, but then it will expand up. So long story short, you can do both.
I guess, Slack is often used now by DevSecOps teams to do chat ops and, notifications from CI/CD pipelines and stuff like that. I assume with maybe stuff like the bridges or something like that, you could tie something like GitLab and maybe Jira and Confluence back to Matrix.
I guess I kind of take this almost for granted because since day one, or possibly I think day 7, we have built all of Matrix over Matrix. And, we're a bunch of software developers and we maintain, thousands of servers around the place. And so one of the very first things we did was to build a GitHub and a GitLab integration so that you could file bugs straight from the command line, and it would log in with your actual identity on the third-party platform using OAuth. So you literally are filing bugs as yourself. You're getting updates coming in the context of the room. If somebody mentions a bug by name, then it will get embedded and you can interact with it from within the app. And then more recently, we have really fun technology called widgets, which allows you to embed arbitrary functionality into your chat rooms. So you're literally taking a chunk of a web page and embedding it so that everybody in that chat room will see the same web content. I have no idea why nobody else seems to do this, because once you have it, you just can't go back. If you find yourself needing, I don't know, imagine that you want a really fancy classification tagging system so that you can tell in your MPE environment precisely who's allowed to see this room. Are we going to add that natively into Element? Oh my God, no. We'll confuse all the open source people and they'll wonder what on earth we're up to working with information classification hierarchies. But if you have it as a widget, then suddenly the top 10% of every page can be a nice, great big red, green, yellow, whatever tagging system, and you can go wild with custom functionality. Or it could be Grafana graphs, or it could be your Salesforce pipeline, or whatever functionality you want to integrate. So yeah, the DevSecOps is actually great, mainly because we've been dogfooding it to build the whole thing for the last 8 years.
Yeah, exactly. That's I guess are you raising money? Are you planning on doing another round, or how are you doing?
Yeah, so we've raised them $48 million as Element so far. We did our Series B last year. Right now,
okay.
Yeah, so I mean, right now, on one hand, the market is in a bit of a macroeconomic mess, but on the other hand, particularly with NATO hopefully coming on board and other sort of countries in the West starting to converge. I think in the last week, I've started speaking to 2 more countries who turn out to have actually been using Matrix themselves independently for the last few years and have got to the point that they need to go to production, at which point they ping me as the CEO at Element to say, hey, how do we get support? Can we use your enterprise and install a product? So frankly, I'm scared that we might have a catastrophic success scenario where if everybody wants to go live at the same time and everybody needs their cross-domain gateways and they need their special integrations, we just don't have the people to be able to do all of the integrations. And so we are looking for we're considering doing another round right now, literally this week. So if anybody is listening and interested in investing in this sort of thing, then this could be the right time to be in touch.
I'm looking to buy a company under 500 million. I don't know if you already crossed that valuation, but I'm always here for you. Think about us.
You can talk about it. Who knows? Right. It was somewhere around there.
Yeah, well, here we go. We can play with numbers. So, all right. So let's see my last question for you, and then we have a few questions from the public. Um, so what's your take on what's happening in Ukraine, and what keeps you up at night?
Well, I mean, I think there's some overlap between the two there. An interesting thing about Ukraine is that we discovered quite late in the day that they had been using Matrix themselves via the open source deployments, checking it out on GitHub. And we're aware of at least 3 different sort of clusters of deployments because it's uniquely suited for the situation that they're in, that they can run multiple deployments in different cities and different data centers or outside of data centers, so that even if the comms goes down due to infrastructure attacks or power outages or internet connectivity problems, then at least people locally within that environment have a hope of being able to talk to one another. And some of these have been deployed by NGOs. And you can go and look one up at decoms.net.ua, but at least 2 others have been done on the military side of things. And it was just very reassuring to see that our tech was just being picked up and hopefully helping people in a pretty nightmarish situation to improvise dynamically and get the advantage of not having to be dependent on a single cloud vendor who might be compromised in some capacity. Instead, they don't have to trust anybody. They don't have to trust us. They can just go and check it out themselves. And I was listening to Eric Schmidt, formerly of Google, enthusing about what he had seen them do there. And the 2 examples he gave was taking drones from DJI or whoever it might be, but then immediately vaping them and putting their own custom firmware on that they trust in order to do whatever creative things with them. But also on the comms side of things, by running their own decentralized comms infrastructure, they don't have to trust anybody, and they have this geographically decentralized resilience. So really fun to see our stuff working there. Honestly, in terms of what keeps me up at night, one of the downsides is that we have created a global end-to-end encrypted military-grade communication network that anybody can use. And so, as well as the good actors, necessarily the bad actors are going to be on it too. And the last thing we ever want is Matrix to kind of be seen as the dark net, like the place where the bad guys hang out. And obviously, we have a lot of good guys on it today, but there are bad actors too. And we feel a responsibility to make sure that the organizations and the users on the network can apply their own rules in terms of choosing who to interact with. And before you know it, you've basically fallen down a free speech versus censorship versus disinformation campaign rabbit hole, the sort of thing that Elon is dealing with or failing to deal with at Twitter right now. And so we're having to build into the protocol basically the ability to empower people to filter stuff based on their own requirements. And there is no centralized authority there. There can't be, because it's not a centralized network. Instead, it's letting people say, hey, I don't want to see any not safe for work content on Matrix, or I don't want to see any terrorist content on Matrix, or whatever it might happen to be. And it's a hard problem to crack. We've got a bunch of people working diligently on it. And right now, Mozilla and a few other companies are running this already in production as a way to have control over the Wild West, which is out there. But it kind of reminds me of the early days of the web, where at first, when you search for something on a search engine, you could find all sorts of weird stuff almost without trying. And then people improved the search engine results in that instance to tune it based on what they thought you wanted to see. Whereas in Matrix, we're taking the opposite approach, and we're giving the users the access to the knobs and dials, so that if they want to dial down the NSFW stuff, they can, or if they want to dial up the NSFW stuff, they can as well. But at least you have those primitives in the protocol. So that's literally what I lie in bed at night worrying about, making sure that the good guys can hide the bad guys for their definition of good and bad.
Yeah, the key is to let them decide the definitions. Otherwise,
Oh yeah.
Go back to free speech issues again.
Yeah, and don't worry, we are never ever advocating any kind of centralized authority or a kind of moral absolute what is good and wrong. Instead, the entire system is morally subjective and lets people define their own rule sets, and then they kind of buddy together in their tribes. And if your particular tribe thinks cats are evil, then you can go and get rid of the cats. And if a different tribe thinks that dogs are evil, blah blah blah. So I mean, the whole thing is relative, but it's relatively unique because the internet doesn't tend to work like that.
Yep, exactly. All right, so a couple of questions here before we let you go. I know we're already out of time, but quick. How can a user know if the client published by the third party is entirely and only following the Matrix protocol and doesn't have a kind of baked in psycho event login or whatever malicious stuff in it?
Yeah,
I guess
excellent question.
we have to check the client, right?
Yeah, I mean, excellent question. It really goes back to the whole signal versus matrix ideology. That do you want to have a network where there is a handful of clients or even just one official client and they publish the hash of that software and you have to trust that they have audited the whole thing and it's not malicious? Or do you want an open network where anybody can pitch up with a client and build a matrix functionality into their drone or their tank or their Nintendo 3DS or whatever, but in exchange, a malicious client could be doing terrible things with your data. And yeah, as you were saying, Nick, it's basically just a matter of who do you trust to run the software on your computer, full stop, and make sure that the third party is one that you trust and has been audited. Hopefully it's open source and you can grab the source and you can audit that and check its dependencies and build it yourself. And Matrix gives you the option of building it yourself and auditing it. And in terms of trusting trust, you can build the whole thing in a high side, secret, or above environment if you want, if you're that paranoid. Whereas you just can't do that in a centralized system like Signal. You just have to trust that they didn't go and screw it up. So it's trade-offs, honestly. Don't use dodgy clients from people you don't trust.
Yeah. That makes sense. Pretty much like any software. All right. Patrick was saying, wouldn't there be an easy aggregation spill issue with automated movement of data down? I guess he was worried about the CDS and the push down, which is always a sensitive subject in governments.
Yeah, quite right. Honestly, the architecture of the CD cross-domain guard is letting you apply any data loss protection rule set that you want. So if you just want to make sure that nobody can ever communicate from high side to low side and that it's just used for one-way ingest of data or messages, that's fine. And we've seen some people deploy it in that configuration. But more often, if you have a room that is tagged at a low side classification and you have people on the low side network, do you really want to have a swivel chair to be going and communicating with folks in the high side facility down to the low side network? I mean, hopefully you can trust them if the room is low classification tags and they've got data which is already at low and they want to push it out to the other guy. No, that's not an unreasonable thing to do.
The issue is mentioning the issue is mentioning also is if you do a high volume of content sometimes, even though one is in class, the aggregate could become classified.
Yeah, for sure. And obviously you could do things like have timestamps as metadata, which could be used to exfiltrate information from the high side. And yes, on aggregate, you could you might end up with patterns emerging just from the flavor of data that is flying around. Again, we leave it up to the deployment configuration to...
I was never a big fan of aggregation augmenting classification anyway. That starts opening the kind of worm of everything gets classified, and it's a very dangerous pattern, very subjective too. So
yeah, in the end, if you've got a bad actor on the high side, already you've got some pretty major problems. And a good example is just plain old steganography, that they could just start sending messages through with some keywords embedded in them in order to leak information through that way. And it's not aggregation, it's just steganography. But if you took that to its logical extreme, it's like, oh crap, we can't have any data going from the high side to the low side anymore. So
exactly.
Yeah.
Yep. That's spot on. Well, Matthew, wanted to first thank you for all the great work you've done, not only for the world and the universe, but also sharing with us a lot of great insight. I think you convinced us that this is a great capability to implement decentralized communications and really open the door to fixing all the struggle we've been facing, particularly with the vision partner engagements, but pretty much across all companies out there. So I wanted to thank you for the time. I'm going to give you the last words, but before that, I wanted to remind people of who is coming next week. So next Tuesday, we're going to have another guest that came to see us a year ago, but coming back, Zach Butcher, the head of product of T-Trade.
So I've lost audio, I'm afraid, Nick, for the last couple of minutes. So I couldn't hear that. But just wanted to say thank you again for having me on the show, and to encourage everybody to have a play with Matrix or talk to us at Element if you want to deploy it at scale. Thanks very much.
Here we go.
Oh, there we go. Yeah.
Can you hear me now? Yeah. It's funny enough, my battery died, so I have a mic. So I'm gonna swap the mic quick so it doesn't die on me again. Just quick. So yeah. So the last for you. So you gave us that. I don't know. I guess you didn't hear what I said about Greg Toohill. Did you hear what I said about Greg Toohill?
Nope.
No. All that was gone. Okay. So next Tuesday we're gonna get Zach on the show from T-Trade talking about the next generation access control. The week after that, we're gonna get Greg Toohill, the former and first federal chief information security officer, and now director of the U.S. CERT. He was also a general in the Air Force, so he's going to give us a lot of great insight on his career and zero trust and a lot of great stuff that he's done. So that's going to be the 29th with Greg Toohill, the 22nd with Zach from T-Trade to talk about his work with NIST on next generation access control. And I guess last words to you again, and that would be all.
Thanks, Nick. No, I was just saying thank you again for having me on the show and for the super deep dive. Hopefully it didn't bore people too much with the technical details. And yeah, if folks are interested, please go check out Matrix at matrix.org. Or if you want to run it at scale, come and talk to us at element.io. Thanks.
Thanks so much for your time again, Matthew. We're so glad you were able to join us. And everybody stay safe and keep up pushing this great work, so our kids have a fighting chance of winning against China 20 years from now. Stay safe, everybody. Bye-bye. See you next week, Tuesday, 1 p.m.
Thanks, Nick. Bye-bye.
Thanks.